Test number 6, conceptual section. So what we got two identical cars. One is going to have an anti-lock brake system. The other is not going to. Both of them are going at 60 miles per hour at the time they lock up their brakes. Okay, so what that means is the car without the anti-lock brake system will skid to a stop. The car with the anti-lock brake system will come to a stop without skidding. So the question is, which one, if any, will come to a stop sooner? Which one, if any, will come to a stop sooner? And then what you need to do is you need to provide an explanation. You need to provide an explanation as to why. So the justification is required. All right, so this is the lecture video. Without the anti-lock brake system, it's going to be tough to control the car, obviously. So the car is going to be all over the place. With the anti-lock brake system, it's easier to control the car, and the car is going to come to a stop sooner. All right, so the vehicle with the anti-lock brake system is going to come to a stop sooner. The question is why? The reason is because the anti-lock brake system is going to generate more friction. So the amount of frictional force generated by the anti-lock brake system is going to be larger than the friction a skidding car experiences. So the next question is, you got a Ford Tempo and an SUV locking up their brakes at the same time. All right, so this does not involve an anti-lock brake system. Both vehicles will skid to a stop. All right, so as soon as they lock up the brakes, they'll skid to a stop. They're going to go into a skid, and then they will skid to a stop. So the question is, which one is going to come to a stop sooner? And once again, you have to provide a justification. You have to provide a justification. Okay, so there's no other way. Explain why. So which one is going to come to a stop sooner, and explain why. All right, so that's what we'll do. Your common sense is going to say that the car is going to come to a stop sooner because it's much less massive. Then again, the reason why the car comes to a stop is because of friction, and friction depends on the mass. All right, so according to your common sense, you will agree with this guy, and this is the guy who's just going to talk about which one is going to come to a stop soon. And as you recall from the lecture, this guy simply is going to say the SUV is going to take a lot longer to come to a stop, and that's precisely what he's saying. So what's wrong with what he's saying? What's wrong with what he's saying is the fact that friction is the reason why both vehicles are coming to a stop. The heavier vehicle is going to experience more friction. So the meaning of that is the following. So here's the sliding friction, kinetic friction that you're looking at. The amount of frictional force that a vehicle generates depends on its apparent weight. What that means is heavier the vehicle is, the larger the amount of friction that it's going to experience. All right, so N represents the normal force, so that's the apparent weight. Okay, guys, I don't want to see a mathematical explanation. Obviously, I'm just taking you through the solution. The only thing I'm interested in is this one. The more massive the vehicle is, the larger the kinetic frictional force is going to be. So more massive the vehicle is, heavier it is, the larger the frictional force is going to be. Vehicle 2 times heavier is going to experience a friction which is 2 times larger. Vehicle which is 10 times heavier is going to experience a frictional force that's going to be 10 times larger. All right, at the end, mass is not going to matter, right? Because the frictional force is going to be proportional to the mass. And that, once again, this is not an explanation that I'm going to accept. Mathematically, things worked out, right? Just as we predicted. Mass didn't matter, it gets canceled out of the equation. So the only thing that matters is the quality of the tires. If they have similar quality tires, the only other thing that factors in is the initial speed. Both of them have the same initial speed, we'll skid to a distance at the same time. So the short answer that I'm looking for is both of them are come to a stop because of friction. Friction depends on the weight, right? So vehicle 10 times heavier is going to experience a frictional force which is going to be 10 times larger. All right, so as a result, both vehicles will come to a stop at the same time while skidding the same distance. All right, so anti-lock brake systems lock up the brakes 18 times per second. So the question is why? What's the idea behind the anti-lock brake system locking up the brakes 18 times per second? All right, so here's the reason why. Anti-lock brake systems will lock up the brakes 18 times per second. Short answer is because locking up the brakes 18 times per second is going to allow you to be able to maximize the average static frictional force. What does that even mean? Imagine that you don't have an anti-lock brake system, so what happens? You lock up the brakes. The result, the static frictional force becomes maximized. As soon as it's maximized, the car is going to go into a skid. It's going to start to skid. So static friction turns into kinetic friction at that point. Static friction turns into sliding friction at that point. And notice that only this portion of the static frictional force is larger than the kinetic frictional force. Only this portion is larger than this kinetic frictional force. So the anti-lock brake system is going to pump the brakes within this region. More often it pumps the brakes, the larger average static frictional force will be. So the whole idea of pumping the brakes 15 times per second, 15 times per second, 20 times per second, depending upon the car, is to maximize this average static frictional force. And because this average static frictional force is larger than the sliding friction or kinetic friction, this car is going to come to a stop sooner. All right, so the last question is a cat falling from the top of the Sears Tower. So we're gonna cat falling from the top of the stairs tower. It's gonna be able to survive the impact with less severe injuries than a cat falling from the second floor. All right, so the cat falling from the top of the stairs tower is gonna end up surviving the impact with less severe injuries than a cat falling from the second floor. So the question is why? And so what do we have? We got a cat falling from the top of the stairs tower. And the stairs tower is about 1,450 feet tall. It's 1,450 feet tall to the top. If you go to the top of the antenna, it's going to be about 1,500 feet tall. So just go to the top of it. And then, I don't know how you're going to do it, but let's assume that you can just hide a cat somewhere and then bring it to the top and just drop the cat and then hide. Okay, so here's your cat, falling cat. Here's the bird eye perspective of it. Now, boom. You expect the cat to splat. You know, that's not what happens, right? So this is something that we discussed before. So contrary to what you expect, the cats tend to do better in longer distance falls. In fact, anything over 70 feet, the cats will do just fine. The reason is because it's going to take about 70 feet for the cat to reach its terminal velocity, which is about 60 miles per hour. All right, so and then the cats get extra muscles that would allow them to absorb the impact better. Once they reach their terminal velocities, what happens is they stop accelerating. Because they stop accelerating, muscles are relaxed. And when you have relaxed muscles, what happens? The muscles are able to absorb the impact so much better. So what does that mean? Most of you guys kind of forget to explain that, because when you say muscles absorb impact, what does it mean? Because you're just it's if you don't explain it, it doesn't mean anything in physics. So that requires kind of an explanation. The absorbing impact, in this case, it means the muscles are able to generate a large enough impact time because they're relaxed. And that in turn reduces the acceleration. So that's what I was looking for that particular question. So this is the repetition of the same question from test number 5.